Well, we're solving radicals. We use some of the same methods we've been using. So let's start out small. It has a radical in it. Yeah. That's what I say that. It's just a rebel. Again, you solved enough equations, you can probably do the entire thing. The only key is understanding a few nuances of the roots for the radical. Okay. I'll show you those, and you do actually have to check your answers. You have to actually plug it in to make sure it still works when you get it. That's the other problem. They require a little bit more work if you have to plug your answer and check it. Okay. So, step number 1 here would be to isolate the radical, if you can. So we need to isolate the radical. Yeah, pretty much. You subtract 8. So, now it's isolated. Is that possible? Yeah. And a cube will give you a negative. Oh, yeah. Cubes can give you a negative. Yes. This works. This is okay. So think of it like something like this. This is because that works. Okay. So think in inverse relationships here. Cube roots of negative numbers work because a negative number cubed is a negative answer. Okay. Does it work for square roots? No. Fourth roots? No. Okay, no even roots. Odd roots are okay. Okay, this works with odd roots. But not with even roots. Keep that in mind. It would just be a no solution. Might run into one, we might not. But wait, sorry, did you run into that one? This is square root. Would that be like any answer you should just say no? It would be a complex answer, not a real answer. How do I deal with roots? Yeah, how do I get rid of this one? Amazing. Amazing. You use, yeah, exactly. These are called inverse. You hear that word? Inverse functions? Those are inverses. Guess what? Adding and subtracting are inverses. Multiplying and dividing are inverses. So when we solve equations, we're just using inverses. Math teachers are very poor at teaching that word. Most of the time when we say it's the opposite, please don't use that word anymore. Okay, these are inverses. The whole concept of inverses is a big idea in math. Do we do inverse functions in here yet? Yeah. Like, yeah, so that whole idea is all wrapped into one bubble. What's negative 4 cubed? And so x is what I tell you earlier. Yeah, check your your answers. It sucks sometimes, but sometimes you get answers that don't actually work. Okay, so you do have to check your answer. Does that work? Okay, negative 64? Right. Root of negative 64 is does that work? What? No. That's not. Okay. Black. No. Not racist, I promise. Yeah, it's the worst. Alright, so there's an easy one. This is a basic solving radical. You will run into some that are a lot more messy. Now it's a negative. Thanks for that, Kenyon. Shut up, Kenny. You're about 5% of the student population. Actually, I'm not. The science is a very good thing. Chemistry is not. Okay, let's solve one more. A difficult one. And I'll let you this. Give me about 5 minutes and then we're done, okay? Focus on it. These ones you need to see. Can I isolate the radical? No. It's nasty and messy. Okay, so you're actually going to have to do it two different squares of each side. Okay. Got it, right? Squares. It's a mathematical word. You don't understand it. Okay, so we got one root here isolated. That's as far as we can go right now. Okay. Because there's one over here that's going to cause us some mess. So I need to square both sides, right? Yeah. So if I do that, I end up with x plus 10 over here. Well, I have to do the right side. Yeah. Thanks, kid. Sean Cutter. You cannot distribute a square over a subtraction addition thing. Please don't try that. That means that for two of those, you have to FOIL. Okay, so FOIL, first times first. Then we have the outers. And that's all you write, 5 times root 3 minus x. And then the inners. And then last times last is negative times a negative, and then what we end up with is a root times a root of the same thing. It's whatever's inside. Okay, the roots disappear. Thankfully. Otherwise it would be and this is not function. So you FOIL, take it. Please. Playing cards with my daughter. 4.5. Okay, combine like terms on the right. This is minus 10. Oops. Yep, I could have done that better. That's 25 plus 3. 28, and then we have minus x. So thankfully there's just one root here, right? Now we can move everything over and isolate it. So add your x, and subtract your 28. Cancels. These cancels divided by -10. Yeah. It creates decimal messes. You can divide by -10 if you want. Fair game. But you don't have to. Okay. I can go ahead and do this. Right now. That is a multiplication, right? I can distribute the square. Okay. Over addition, I cannot. And here I can. So, you have 100 times 3 minus x, the root's gone. I know. Dodging bullet there. And guess what we get to solve? Quadratic. And this will be 4x squared minus 72x. 18 times 18 equals 56. Oh, I see 16 squared. Okay, back up that. Yeah. Distribute here. And we'll move everything to the left. 3 up 4. Add 100, so we get plus 28. Subtract 300. All the big numbers are gone. You with me? I lost anybody. Okay. Okay, I'm going to give you some advice here. Is there a greatest common factor? Get rid of it. Right. Divide by 4 on both sides. This is that number one factor of that. I'm going to move this up over here. On your repeat that. Factor that? Yeah. What are factors? Thanks, Melissa. I'm sorry for insulting you like that. So our x values are -1 and 6. -6, right? Gotta check. So, anybody lost anywhere in here? And a sea of letters or numbers? I made a blue on purpose. They win. Here. Okay, so you good here? Blue. Sorry, distributed. Now I move 300 over here. Get a point more and add 100x to get 28. Then we divide by 4 to get rid of the common factor. Make it nice and pretty. So, does -1 work? And 3, and then 3. Yep, so -1 works. Okay? The 6 works. We get 2. And 2. You going that right? Okay, so they both work. We're good to go. You gotta check them though, because sometimes it'll throw like a negative number in the root. And you have to actually get rid of that solution. Any questions? And any of those? These lines, these get kind of messy. In the past, I know our students give up. Okay, don't give up. Try to work it through. These are going to take you 5 minutes each. Okay. But you got to keep your work organized, keep it nice and neat and clean. I don't care how much paper you use. You could turn 5 pages in and I'm fine with that. Yeah, I know. So if you have to top the bottom on your paper, if you use the whole page for one, that's fine. Okay? I'll give you more paper. Okay, whatever. Just make sure it's neat and clean and you can read it. Right? Yeah.
Are there any other things that when you know that it's going to longer than this?
Hey. No, I would have to look through it to make sure I was doing I don't know. We probably have some things that are equivalent to this. Yeah, we're gonna have stuff this fall. The start of next semester is solving equations with sine and cosine and tangent, straight equations, and those can get kind of nasty. So, yeah, we will see more work like this. The biggest thing you can take out of pre-calc is what do the graphs and functions look like, and how do I solve equations. You want like 2 things to focus on this here? Oh, yeah. This chapter is super important. Okay. You have 15 minutes. Let me know if you have any questions. If you have AP lit homework, we'll finish. Feel free. I give you permission today.